Hello fellow survivors and welcome to the Walking Code C++ programming series. This is lesson 11. We're going to let chance decide our fate. What we're going to do in this lesson is we are going to learn about generating random numbers. Why is random numbers in quotes? We'll find out soon. We're going to add more header files to our programs. Right now, up to this point, we've just been using one header file. And we're going to add more because the more header files we add to our program, the more functionality we add to our programs as well. And we're going to learn how to use more of the built-in functions of the C++ library. By adding these header files, we add functionality. We can use more of the built-in functions. We don't have to do everything ourselves. Alright, generating random numbers. Now, why is random numbers in quotation marks? Well, when we generate random numbers with a computer, the numbers aren't really random. They're based on an algorithm that simulates random behavior. Now, an algorithm is just a mathematical formula. Don't let that throw you. But these algorithms are really quite complex, which is why we don't want to do this ourselves. So, in order to use the algorithm that comes with the C++ programming language, we are going to include the cstdlib, or the C standard library header file, and we're going to use the rand function to generate random numbers. We know that this is a function because of the open-close parentheses after the word rand. That lets us know that's a function. It's not a variable. It's not a statement. It's a function. Alright, and we use these functions in our statements to do different things. So let's take a look at how to use the rand function. Alright, I can create an integer x, have it equal to rand, and I can see out x, inline. I ran this program twice. It's just a simple program I ran. Now this isn't going to be in the lab of this lesson, but I just wanted to show you guys that if I just add the C standard library header and int x equals rand, and I see it out, or I try to use it in a formula or something like that, I get the same number each time. This is two separate times I ran this program, and I got 41 each time. Alright, so I ran the program twice and got the same number each time. What the heck is going on? You shouldn't get the same number each time with a random number generator. Well, what we have to do, I kind of tricked you here. What we have to do before we use our random number generator is we have to seed the random number generator. And when we seed the random number generator, we're just giving that algorithm that it uses to generate pseudo-random numbers or fake random numbers. We're seeding that with a value. Okay, so it starts at a random spot. We use the srand or the seed rand function to do this. And what we're going to feed into the srand function is the system time, because the system time is always going to be unique. Okay, it's always going to be a certain month, a certain day, a certain year, a certain hour, a certain minute, a certain second, that type of thing. Alright, and in order to use the srand function, or excuse me, the time function, we're going to add the hashtag include ctime header file to our program. And we'll see how to do this in the lab portion of this lesson. Here's an example. We got this big long, looks like convoluted string of code here, srand, open parentheses, static underscore cast, unsigned integer, open parentheses, time, open parentheses, 0, close parentheses, close parentheses, close parentheses, semicolon. Now, sometimes it helps if you read your code from the inside out, and this is a perfect example of this. What I'm doing is I'm using the time function, and I want to know the time it is right when this statement executes. What's the system date? What's the system time? This and that and the other. So I get a unique value. I'm going to cast that into an unsigned integer. And when you cast a variable from one data type to another, you're changing its data type. Right now I'm taking the time and I'm casting it to an unsigned integer. An unsigned integer can only be positive. And then I'm taking this value that comes from this function, being fed into this function, and I'm feeding it into the srand function. Okay, so now I've just seeded my random number generator. Now, when I make I take my integer x and set it to a random value, or set it to the value of the rand function, whatever that returns, and I output the screen, and I run it twice, I get two different values. I get 10778 and 11199. Alright, so now I'm getting random numbers. Well, you know, those numbers are different, but is there any way to get a more sensible random number? Like maybe between 1 and 6? Like rolling a classic 6-sided die like you would in Yahtzee or Monopoly or something like that? Because you don't get, typically you don't need random numbers that big. You need random numbers between a range, like 1 and 6 or 1 and 20 for you D&D players out there. 1 in 100, 1 in 10, that type of thing. Any type of polyhedral die you should be able to simulate via computer. And the answer to that is yes, there is. We can use the modulus operator to return the remainder of the random number divided by another number. For example, if I create another integer and I name it die, for die let you cast, not die like kill something, and I set equal to whatever the value of x is, modulus 6. Now remember what the modulus operator does. The modulus operator returns the remainder of an operation. Alright, now because I am using the modulus operator in 6, I'm saying take the value of x, divide it by 6, and give me the remainder. Now, the remainder of this operation is going to be between 0 and 5. Because those are all the remainders that you can have, those are all the integer remainders you can have when you divide by 6, is between 0 and 5. You cannot have 6 as a remainder, otherwise 6 goes into 6 one time with no remainder. So what I'm going to do to get my value between 1 and 6 is I am going to add 1 to it. Okay, so let's say x is 60. 60 divided by 6 is 10 with a remainder of 0. So this in parentheses is going to equal 0 plus 1 is going to equal 1. Okay, let's say this is 55. No, let's say it's 59 rather. Okay, well 59 divided by 6 is going to equal 9, remainder 5. 5 plus 1 is 6. So we can get our range of values between 1 and 6, inclusive, using this this method here. Don't let the word inclusive mess with you. It just means the values between 1 and 6, including 1 and 6. Okay? So, what we're going to do in our program is we are going to say that we have a 1 in 6 chance to shoot a zombie in the head. Alright, if it's a 1 in 6 chance, if we cast the die and we roll a 1, boom, we shoot the zombie in the head and he dies. Anything other than that, 2, 3, 4, 5, or 6, we shoot him in the torso, leg, arm, whatever. Anything but the head. Maybe we miss him. Who knows? But he's still coming at us. Alright, and we're going to use concepts from the last couple of lessons for this project, meaning we're going to use if statements, that type of thing. So we're just going to tie a whole lot of stuff together in this project. So if you're not familiar with the last couple of projects, go back, look at the lecture, look at the labs, get really familiar with this stuff before we move on. If you don't know those concepts, we're going to be using them in the future. Learn them. Have any questions? Leave me a comment. Thanks a lot for watching.